know the scene, right? A brilliant flash rips across the sky, and a few seconds later, that deep rumble shakes the whole house. Lightning. It's one of nature's absolute best shows, but it's also one we don't fully get. So let's dive in and uncover some truly shocking facts behind that flash. All right, let's kick things off with something that sounds like it's straight out of science fiction. We see lightning as this big flash of light, but what's really going on there is an amount of heat that's, well, it's almost unbelievable. Okay, get ready for this number. A single bolt of lightning heats the air around it to about 30,000 degrees Celsius. For all of you thinking in Fahrenheit, that's a jaw-dropping 54,000 degrees. To put that into perspective, just try to picture our sun, that giant nuclear furnace sitting at the center of our solar system. Well, the surface of that star is actually cooler than a bolt of lightning. Just think about that for a second. For a split second, that flash in our sky is hotter than the star that warms our entire planet. It's wild. So we've established the incredible, mind-blowing heat. But what about the physical size of one of these strikes? How does all that raw power actually look up there? Yeah, a single bolt isn't just some quick little flash. It's a massive electrical discharge that can stretch for up to 5 miles, or about 8 kilometers. That's long enough to connect one side of a small city to the other. It's literally a river of plasma flowing through the sky. We all have that classic image burned into our brains, don't we? A bolt comes crashing down from a cloud and smashes into the ground. But is that the whole story? I mean, does lightning only strike down? The answer is a big fat no. Lightning is actually a two-way street. It can shoot up from the ground too, especially from really tall things like skyscrapers or radio towers. Some of these structures get hit dozens of times a year, with bolts that literally look like they're shooting up into the clouds. And of course, you can't talk about lightning without its famous partner in crime, thunder. They're not two separate things. They're two parts of the exact same event. And it all goes back to that insane heat we started with. So here's the play-by-play. That lightning flash, hotter than the sun, instantly superheats a tiny little channel of air. Well, that air has to go somewhere, right? So it expands explosively. We're talking faster than the speed of sound. This creates a massive shockwave. And what we hear a few moments later is just that shockwave rolling through the air. That's thunder. It's the sound of air literally being ripped apart. Okay, so we're getting a handle on a single strike. The crazy heat, the sound it makes, but what does this look like on a global scale? When we zoom out and look at the entire planet, the picture gets even more staggering. At any given moment, no matter what time it is, somewhere on this planet, lightning is striking. And not just every now and then. It's happening about 100 times, every single second. By the time I finish this sentence, lightning will have hit the Earth hundreds of times. It's basically a constant global electrical storm. And here's something else. Not all lightning comes with a big downpour. There's this really dangerous thing called dry lightning. It's when a storm creates all the thunder and lightning, but any rain it produces actually evaporates before it can hit the ground. So what do you get? You get all the fire-starting power of a lightning strike with absolutely none of the rain to help put it out. So what happens when all that energy actually makes contact with the surface of our planet? It doesn't just vanish into thin air. Sometimes it leaves behind a pretty fascinating and permanent mark. This one sounds like something straight out of a fantasy novel, I know. But when a bolt of lightning, with all that incredible heat, slams into sandy soil, it can instantly melt the silica in the sand. And the result is this incredible thing called a fulgurite. These are natural, hollow glass tubes that perfectly trace the path the lightning bolt took as it shot into the ground. You're basically looking at fossilized lightning. It's a beautiful, fragile record of an unbelievably powerful event. We tend to think of lightning as just destructive, a force you want to avoid at all costs. And while that is definitely true, it's only half the story. Lightning is also, surprisingly, a powerful creative force for life on Earth. It's this incredible duality. On the one hand, yeah, lightning is dangerous. Your personal odds of getting hit are low, but thousands of people around the world are struck every year. But on the other hand, the sheer energy of a lightning bolt does something vital. It breaks apart nitrogen molecules in the air, which then mix with oxygen and fall to the earth as a natural fertilizer, literally feeding the plants. This really says it all, doesn't it? It perfectly captures lightning's complex identity. One single flash can be a force of destruction, sparking a massive wildfire.
And at the same time, it can be a force of creation, providing the very nutrients that help that same forest grow back even stronger.
So the next time you see a storm rolling in, remember what you're really looking at. It's not just a light show. It's a planetary process that forges glass from sand and fertilizes the soil beneath our feet. It's both terrifying and beautiful all at once. And it really makes you wonder, doesn't it? If it can do all that, what other secrets are hidden inside that flash?